towards a stationary wood block. The wood block is kept on a rough horizontal surface. The mass of the block is 0.6 kilograms. After the collision, the bullet gets embedded in the block and they move as a single object. The coefficient of friction between the block and the horizontal surface is 0.4. Roman number 1. Calculate the velocity of the block with the bullet just after the collision. Roman number 2. Find the friction force acting on the block after the collision. Roman number 3. How much distance is traveled by the block when it comes to rest?
Right. Thank you very much, dear. Thank you very much. So let's give a try. So what is the meaning of gets embedded? What's the meaning of gets embedded? The bullet will be inside the block after the collision. So if we consider this the situation after the collision, right? If we consider situation after the collision, there will be block will be there, and there will be a bullet in it. Right? Let me use a different color pen. The bullet will also be there. I just use an arrow to indicate the bullet, right? So then gets embedded means the bullet will be inside the block. That's the meaning of gets embedded. Got it? Right. Would you please draw this figure here? You should draw this figure completely. This side and the other side. So before the collision and after the collision. Start there. Did you draw the figure? Who wants more time to draw the figure? Who wants more time to draw the figure? If you have drawn the figure, please send me that you have drawn it. Just send me a message saying done. So if you have sent me a message saying done, then I know that you have completely drawn it, so I can move to the next section. Right. I think time is enough. I think time is enough. So what's the law that should be applied to solve this problem? Somebody please tell me. I will not erase the figure, I promise. Right. What is the law that should be applied to solve this problem? Tamai?
The law of
Hello.
conservation of linear momentum.
Very good. Excellent. We should apply the law of conservation of linear momentum. Linear momentum. We should apply the law of conservation of linear momentum. The law of conservation of linear momentum can be represented by the equation like this. Total linear momentum, LM means linear momentum, equals total initial linear momentum. Total initial linear momentum equals total final linear momentum. Please write this here. So it is said that total linear momentum is not changed. Total linear momentum is not changed. So therefore, total initial linear momentum of an object or a system of objects is equal to the total final linear momentum. So please write it here. Right. At the same time, somebody unmute the mic and tell me the meaning of linear momentum. What does it mean here?
So mass into velocity.
The product mass into velocity. So mass of the bullet is 0.4 kilogram. What is its velocity here?
100 meters minus
100 meters. So let me use the letter U1 to indicate it. So velocity of the bullet before the collision is 100 meter per second. Velocity of the block before the collision is U2, but what is it here? What's the velocity of the block before the collision? It says a stationary block. You see the term stationary block means velocity is very good. Velocity is zero. So velocity of the block with the bullet after the collision, let me take it as V meter per second. V meter per second. So please mark the velocities also here because we need these velocities to work. Right? So velocity of the block, velocity of the bullet before the collision is 100 meter, velocity of the block before the collision 0, velocity of everything after the collision is V meter per second. V meter per second. Okay, dear? Right now, now the law of conservation of linear momentum tells us total initial linear momentum equals total final linear momentum. So total initial linear momentum means the summation of linear momentum of the bullet. Linear momentum of the bullet is the product mass into its velocity plus linear momentum of the block, that is the product mass into its velocity u2. After the collision, they are combined together. They are the total mass of the objects after the collision is m1 plus m2. The velocity of the combination after the collision is v. Right? Can you do the rest and find this the value of v here? We try to do the rest of the simplification and try to find the value of v. Start. Right. So M1 is 0.4. Many of you have sent me the correct answer. I'm so happy. Velocity U1 is 100. Okay. Right. Plus M2. Mass of the block is 0.6. Its velocity is 0. Equals M1 is the mass of the bullet 0.4 plus M2 is mass of the block 0.6 into the velocity of everything after the collision is V. So then 0.4 into 100 is 40. Just multiply and check. So I'm not going to teach O level maths here. 0.4 into 100 is 40 plus 0.6 into 0. 0 into anything is 0. 0 into anything is 0. Equals 0.4 plus 0.6 is 1.0 into the velocity v, right? So then we will get 40 equals 1 into v is v. So we do not write 40 equals v. We should write v equals 40, and we must write the units meter per second. Who got this answer here? Please raise your hands up if you have obtained this answer. Lamai? Right. If there are any mistakes or if there's any errors or if you have not obtained the answers, please write the answer. At the same time, if you have any difficult point, with this question, send me a message to Zoom chat. Right? I'll help you. So please complete the note here. Please write them all. Okay, what's the next question that they have asked here? What's the next question that they have asked? Find the friction force acting on the block after the collision. So how do you find the friction force here? Am I? How many equations are there to find a friction force? We can find friction force by applying F equals ma, but here we can apply the equation F equals mu r to find the friction force. So wait, I want some space to draw the figures, that's why. Right. Right, so let me consider this block with the bullet, right? What is the mass of the block with the bullet there, Lamai? What is the total mass of the block after bullet gets into it? The total mass?
1 kilogram.
1 kilogram, sir. Very good. So I am going to erase this one because I don't have enough space. If you want any more time to draw these things, please take a screenshot. I have to erase it. Right. I think they have given some data also. Am I right there? They have given us some data also. The coefficient of friction, between the block and this given, right? Now we can easily find the answers, right? So we have to draw this figure once again, then because we have to mark the forces. The weight of the object is acting downward as mg. Then there will be a normal reaction force given by the surface. So let me mark it as capital R. So actually we should mark this R and mg forces along the same vertical line, but here I have kept a small gap. Or we can mark this R force somewhere here. That is also possible, right? So please draw this figure again. Please draw this figure again because we need these things, and we should mark the friction force acting on the object. Should mark the friction force acting on the object like this, right? Please draw this one. So friction force acting on the object is, I'll mark it as Fr Newton. So Fr Newton is the friction force acting on the object. Mg is the gravitation attraction force given by the Earth, and the normal reaction force is capital R. Normal reaction force is capital R. Okay, dear. Draw this figure. After that, let's do the calculations. Right, you see the object is not moving vertically upward, it's not moving vertically downward. Therefore, R and mg forces. Lamai, what is the relationship between R and mg forces here? Object is not moving up, object is not moving down. Therefore, yes, Kuda, try again.
They are equal, sir.
They are equal, sir. Very good. Very good, they are equal. R and mg forces are equal. We no need to write the reasons. And here what the capital M means M1 plus M2. M1 plus M2 is capital M. That is M1 is 0.4. M2 is 0.6. So it means just 1 kilogram. Right? So please write that capital M is 1 kilogram. Then the next relationship is R and mg should be the same. R equals capital Mg, right? So capital M is 1 kilogram. G is 10. 1 into 10 is 10. So it is 10 Newton. So we have found the normal reaction force as 10 Newton. Right. Then how do you find the friction force there? If we know R, if we know mu, we can find the friction force. Let's use the equation. Friction force equals mu R. As I do not have the letter mu here, In this app, letter mu is not available, so I use the letter simple u instead of mu, but it's okay. Value of mu, the coefficient of friction, between the block and the horizontal surface is given as 0.4. The value of mu is given as 0.4. The value of R is found as 10. Then what is the friction force here? What's the friction force, Lamai?
4 Newtons, sir.
4 Newtons, sir.
Very good, very good. 0.4 multiplied by 10, that is 4 Newton. 4 Newton. Okay, so we have found the friction force also. Right, initial velocity, the velocity of the block actually, after the collision, the block starts to move with a velocity of 40 meters per second. After the collision, the block starts to move with a velocity of 40 meters per second. Right. So, due to the friction force, what will the velocity be increased or will the velocity be decreased? Somebody please tell me here.
Decreased, sir.
The velocity will definitely be decreased due to the friction force. And finally, velocity of the block will be 0. Am I right here? Right, so star point and right. Put a star point and right. Due to the friction force, the velocity of the block will be decreased. The velocity of the block is decreased and velocity of the block is decreased and finally it comes to rest. Rest. Due to the friction force, the velocity of the block is decreased and finally it comes to rest. Okay, dear? Due to the friction force, velocity of the object is decreased and finally it comes to rest. Right, so let me draw that figure. Let me draw a figure. If you want, please take a screenshot of everything because I'm going to slightly change this figure. Right, now I am interested in this block. I'll slightly reduce its size because I have to manage the space. Actually, I do not worry about this block called blood. Sorry. Right. So I'm not interested in these R forces. I'll erase them. I'm not interested in this arrow. I don't want this arrow and this. Right. But I need the friction force to find the acceleration. Actually, not the acceleration, deceleration. Right. Let me draw a block also. So there is a block like this. Friction force of Fr Newton acting on me. So due to the friction force, the velocity of the block reduces and finally it comes to rest. Please draw this figure here, Lamai. Please draw this figure. Right. Somebody please tell me the method that I have that I should use to find the acceleration. Actually, there will not be an acceleration. It will be a deceleration. How do you find it here? How do you find this acceleration or deceleration? Lamai? So here I have marked the acceleration as simple A. I want to find the acceleration. So what should I do here? Whether we want to find acceleration or deceleration, we should apply F equals ma. By applying F equals ma, we can find acceleration or a deceleration, right? So that's the method, right? So let me apply F equals ma to this object. Can you hear me here? Lamai, can you hear me properly?
Yes, sir.
Right. Thank you, dear. Thank you very much. So let me apply F equals ma to this object. F equals ma to this object. So we are working with vectors. Therefore, it's a must for us to mark the direction. So I apply F equals ma to this object. I apply F equals ma to this object along the horizontal direction. So this is the direction that I have selected for the equation. To this direction, I apply F equals ma. Okay, dear? We have applied F equals ma to that direction. But what is the direction of the Fr force here? Fr is the only force acting along the horizontal direction. I apply F equals ma to the right hand side because object is moving to the right hand side. As the object is moving into the right hand side, I have applied F equals ma into the right hand side. But Fr, the friction force, is into the left hand side. So direction of the equation and the direction of the friction force are opposite. They are vectors, therefore we must use the minus sign with the Fr force. Why did I use a minus sign with the Fr force here? Because direction of the equation and the direction of the Fr force are opposite. When the directions are opposite, we should use the minus sign. That's how we work with vectors. Mass of the block with the bullet is 1 kilogram. Acceleration is simple E. So minus Fr is found as 4 Newton. Minus 4 equals 1 into A. So minus equal 1 into A means A equals minus 1. Unit is meter per square seconds. Okay, dear? Right.
Minus 4, sir.
Yes, dear?
Minus 4.
Yes, minus 4, yes, mistake.
Minus 4 meters.
Yeah, minus 4 meter per square second. Right. So please write them all here. Please write them all. Right. So please remember to consider the directions when we work with vectors. Object is moving to the right hand side, so I have applied F equals ma to the right hand side. But the only horizontal force acting on the object is into the left hand side. So direction of the equation and the direction of the Fr force are opposite. So I have used the minus sign with the equation. Write them all here. Right, now we can find the time taken for the object to come to rest. To find the time taken for the object to come to rest, we can apply the equation V equals U plus A. By applying the equation V equals U plus AT, we can find the time taken for the object to come to rest. Final velocity is 0, initial velocity is 40, acceleration is minus 4. That's the point. Acceleration is minus 4. The time taken is simple t. So minus 40 goes to the other side as positive 40 equals 40. So the multiplication 4 goes to the other side as division 4. Then we will get t equals 40 divided by 40 divided by 4. 40 divided by 4 is 10. So what's the time taken for the object to come rest here? 10 seconds. Who got this answer earlier than me, dear? Who got that this answer time taken for the object to come rest as 10 seconds? Okay, very good. Very good. All the equations we should use the direction. We must indicate the direction, right? So after that, we can find the distance traveled by the object when it comes to rest. Somebody unmute the mic and tell me the equation that we should use to find the distance traveled by the object when it comes to rest. What's the equation?
S is equal to U.
S equals 2t plus half it is squared, sir.
Very good, very good. We should use students answering me. I'm so happy. So we should apply the equation. We should apply the equation. S equals ut plus half at square to find the distance displacement of the object, right? So here u is 40, time taken is 10 plus half, acceleration is minus, so it is minus 4 into time taken is 10, and we should get the square because t is square, because it is t square is equal ut plus half at square. Okay, Lamai? Right. So this is the equation that we must use, right? Here, let me use some brackets, then things will be much clear. Right. What is 4 times 10 here? Lamai, what is 4 times 10? Yeah, 4 times 10, sorry, 40 times 10, sorry, 40 times 10, 400. Here you see this positive sign is there, should be multiplied with the minus sign. Positive sign multiplied by with minus sign, that is minus plus into minus minus. And here 4 is there, 2 is there. Half into 4. Half into 4 means 4 divided by 2. 4 divided by 2 is 2. Into square of 10. Square of 10 is 100. Square of 10 is 100. So then 400 minus 100 times 2 is 200. So 400 minus 200 means 200. So what is the distance traveled by the block when it comes to rest here? Lamai?
200 meters, sir.
200 meters. Is it clear for all? Are there any doubts? Are there any difficult points? If so, please ask. If you have any doubts or difficult points, please ask. I can help you. Right. Please take a screenshot. If you want any more time to write, please take a screenshot. I'm going to go to the next section, next question and next section. Right. So if you think that you want some more time to write the things, please take a screenshot. Right. Here we have completed Newton's law section and now vertical motion under the gravity section. Right. So now I'm going to select one or two questions to revise vertical motion under the gravity section. Let's discuss question number 21. Right. Somebody please write the heading as vertical motion under the gravity, question number 21. Somebody please read question number 21 here quick.
A student drops a ball from a tall building and it takes 3 seconds to reach the ground. Roman number 1. What was its speed just before hitting the ground? Roman number 2. What was the height of the tall building?
Right, thank you very much. Thank you very much, dear. I would like to use my normal whiteboard for the question. What is the meaning of drop here? An object is dropped means what is the initial velocity of the object?
0, sir.
0. Very good. So
0, sir.
yes, very good. If it is said that object is dropped, initial velocity is 0. So I'm going to draw a figure for question number 21. An object is dropped. It means initial velocity is 0. An object is dropped mean initial velocity is 0. Right? So it falls freely under the gravity and finally it hits the ground. Finally it hits the ground. So object is dropped from the top of a tall building. So this is the building. This is the building and this is the ground, right? The time taken for the object to travel from top of the building to the bottom of the building is given as 3 seconds. The velocity of the object when it hits the ground is v meter per second. We know that when an object falls freely under the gravity, acceleration is equal to simple g, right? So height of the building, let me mark the height of the building as simple h meter. Let me mark it as simple h meter. Draw this figure here, quick. So you can write the heading as vertical motion under the gravity and draw this figure, question number 21 of 600 Questions Tute. We are recalling our memory. We are revising our lesson by using this before we start normal paper class. Right, so this is the paper plus tutorial discussion class, right? I think you remember it. We discussed papers as well as some tutorials. So it's a very easy question. We can easily find this v. To find the velocity v, the easiest method is applying v equals u plus at equation. So vertical downward, let me apply the equation v equals u plus at. Initial velocity 0, acceleration is simple g, time taken is 3. So 0 plus g is 10 into 3. 10 times 3 is 30. Therefore, velocity of the object when it hits the ground is 30 meter per second. 30 meter per second. Who got this answer? Amai, who got this answer? Right. Then we can find the displacement. It means this height. Height is the height of the building is equal to the distance traveled by the object. Am I right? Height of the object is equal. Height of the building is equal to the distance traveled by the object. Displacement of the object is equal to the height of the building. So to find the height of the building, let me apply the equation. S equals ut plus half at square. So distance traveled by the object or displacement of the object is h. The initial velocity of the object is 0, time taken is 3 seconds. Plus half acceleration, the downward acceleration is simple, g, into time taken is 3 and square of that. So h equals 0 into anything is 0 plus half, acceleration is 10, time taken is 9. So h equals 3 square, 3 time taken is 3, square of 3 is 9. 10 divided by 2 is 5, 5 times 9 is 45. Therefore, height of the building is 45 meters. We have discussed all these theorems in our theory class, right? So we are just discussing the tutorials to recall your memory. Who got this height of the building as 45 meters? Raise your hands up. Lamai. Right, let's go to the next question. Let's go to the next question. Look at board. Let me share you the screen and let me show you the question. Right, somebody unmute the mic and read question number 22 quickly. We cannot waste time anymore. We have to stop the class now. So please read question number 22 also. People are very lazy to read. Okay, a body dropped from risk falls half of its total path in the last second before it strikes the ground. From what height was it drops? An object is dropped at a certain height. The half of the total distance traveled by the object travels during the last second. Last seconds mean 1 second. Last second means 1 second. Right, let me draw the figure for you here. Let me draw the figure for question number 22. So if we consider question number 22, an object is dropped, it means initial velocity is 0. Object is dropped means initial velocity is 0. So it falls freely under the gravity and finally it hits the ground. Finally it hits the ground. Right, look at board. If the total distance traveled by the object, if the total distance traveled by the object is simple h meters, if the total distance traveled by the object is simple h meter, the half of the total distance traveled during the last second. So half of the total distance means h over 2 distance. traveled by the object during the last second. Last seconds mean 1 second. Last seconds, 1 second. So if I mark these points, so if this is H/2, this should also be H/2. Okay. If this is H/2, this should also be H/2. So let me mark some points to explain this question easily. Let me mark this point as A, this is B, this is C. Right? Time taken for the object to travel from B to C, let me take it as T1 seconds. Time taken for the object to travel from B to C, let me take it as T2. T2 is the last second. T2 is the last second. So T2 should be 1 second. T2 should be 1 second. Draw the figure here. Draw the figure quick. Right. Look at board here. The velocity of the object at the point B. Let me mark this velocity as V1. V1 is the velocity of the object when it reaches to B. V2 is the velocity of the object when it reaches to C. Right. So I'm going to erase this section. If you want, please take a screenshot. I need some space to write. Now we have drawn this figure. Right. Look at board here. Some students say that this question is somewhat difficult, but it's not so difficult as you think. Look at board here. Look at board. A to B. A to B. Vertically downward, I apply the equation V equals U plus AT. V equals U plus AT. V is the velocity at the point B, final velocity. U is the velocity at A, initial velocity. T is the time taken. Velocity at the point B, V1. Velocity at A is the initial velocity, that is 0. Acceleration is simple G. Time taken is T1. So we will get V1 equals GT1. We know that G is 10. So V1 equals 10T1. Let us mark this as the first equation. Right in here. We will be able to solve this problem within few seconds. Few minutes actually. If we are not tired. Right. Then look at board. Then I select the same section. A to B, vertically downward. I apply the equation S equal UT plus half AD square. I apply the same equation S equal UT plus half AD square. A to B. The displacement from A to B is H over 2. Displacement from A to B is H over 2, half H over 2. Initial velocity 0, time taken T1 plus half acceleration. When an object falling freely under the gravity, acceleration is simple G. Time taken is T1, and we should get the square of it. So H over 2 equals 0 into anything is 0 plus half G is 10 into T1 square. Right? So I can write it like this. If I write here, you will be able to see it. h over 2 equals half into 10 into T1 square. So this 2 and this 2 can be cancelled out. So finally you will get h equals 10 T1 square. That's the second equation. H equals 10 T1 square. Please check whether I have written them all. Please check whether there is any error. Right. Completed. Right. So we have we have applied two equations A to B. So let's do the same thing for B to C. Let's do the same for B to C. Right. Look at both. B to C. Let me apply the equation is equal ut plus half at square. S is h over 2. B object travels from B to C during the last second. Object travels from B to C during the last second. Last second means 1 second. Right? So it travels half of the total distance, h over 2, during the last second. U means velocity at B to C section. When we consider B to C section, U means the velocity at the point B, that is V1. V1 time taken is T2 plus half acceleration simple G, time taken is T2, and we should get the square. H over 2 equals V1. V1 is 10 T1 here. V1 is 10 T1. V1 is 10 T1. Into T2 is 1 second. Last second. T2 is 1 second. Half value of simple G is 10. T2 is 1 second. So it's square. So we will get H over 2 equals 10 T1 into 1 is 10 T1 plus 10 divided by 2 is 5. 10 divided by 2 is 5. Right? So we have many equations, right? So I can do something like this. I'll be able to do something like this. I put the bracket and I'll take 2 to this side. So H equals 2 times 10T1 plus 5. If I want, I can remove the brackets. Then I'll get H equal 10 times 2 is 20 plus 2 times 5 is 10. And let me mark this as my 1, 2, 3 equations. 1, 2, 3 equations. Now try to combine equation number 3 and equation number 2 and find the value of simple t. Take photos and send your answers to my WhatsApp. Right? You just want to take 2 and 3. H equals 10T1 square. H equals 20T1 plus 10. Right? So use 2 and 3 equations and find H1, find T1, then find simple H. Take your photos of calculations and send to my WhatsApp. Then I'll be able to understand that you have learned. Then I'll be very happy. So if you have written, now you can leave the class. That's enough for today. See you. Bye. Good luck.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
Thank you, sir. Bye.